we're going to talk about parallel and perpendicular lines. On my graph, I have 3 lines, 2 red and 1 green. I want you to pay particular attention to the red lines. As I scroll my graph, I want you to notice, do the red lines get closer to each other, further away from each other, or do they stay about the same distance apart? So you'll notice I'm moving further and further into quadrant 1. It doesn't look like these lines are getting any closer together. So I'm going to go back to the center axis. And now I'm going to go into quadrant 3, where the lines continue, and yet they still are not getting any closer together. There's a reason for that. These 2 lines will never intersect, but they are on one plane. We call 2 lines on one plane that never intersect parallel. And there's a way to tell if lines will be parallel. You can look at them, but that's not the way that you can really tell. But if we look at the equations for these 2 lines, we notice that they have the same slope, or the same rate of change, 1/2. Parallel lines have the same slope, or the same rate of change. But looking at these 2 lines, you should notice they have different intercepts. So their y-intercepts, the places where they cross the y-axis, have to be different. But their slopes are exactly the same. That's the definition of parallel lines. But we also have this green line on the graph, and you notice that it intersects the 2 red lines at a point. But I want you to also look at the slope of this green line, -2. This green line is perpendicular to both red lines. Lines that are perpendicular have opposite reciprocal slopes, one positive, one negative, and one the reciprocal of the other. Another way to say that is to say that the product of the slopes equals -1. In other words, if I multiply 1/2, the slope of the red lines, times -2, the slope of the green line, I get -1. That's another definition of perpendicular lines. I want you to replay this video and think about these definitions again before you move on.